In order to integrate this, I promise you, I will not use any kind of U-substitution, and this might be the cleanest solution that you have seen in your lifetime. We know that in order to integrate square root of x, we write that square root of x as x to the power half, and then just use the basic algebraic formula of x to the power n. So x to the power n plus 1 divided by n plus 1. So that becomes 3 by 2 divided by 3 by 2. So we increase that power by 1 and divide by the same power. Now, if you notice carefully, inside of that square root, the power of x is 1. Okay. So I'm talking about inside of the square root. Okay. Even in this function, inside of that square root, the power of x is 1. Okay, so that tells you that this is square root of a linear function, and even this is a square root of a linear function. So we can use the same idea, no U substitution is needed. Okay, so let's just use the same idea that square root of ax plus b can be just written as ax plus b to the power of 1 by 2 with respect to x. Okay, now we can say the integral of this is nothing but same idea. So ax plus b to the power 3 by 2 divide by 3 by 2. But remember that in integral, whatever the coefficient of x is in the linear function, we have to divide by that coefficient of x. Why do we do that? It's just like opposite of differentiation. In differentiation, we multiply by the coefficient of x by chain rule. But in integration, which is antiderivative, we divide by the coefficient of x. So coefficient of x here is a. So we have to write that a in the denominator. So we divide by that coefficient of x after integrating and add the constant of integration c. So we can clean this up a little bit because that 2 is in denominator, it can go in the numerator. Okay, so we can just take that 2 in the numerator. So that's 2 times ax plus b to the power 3 by 2 divide by that 3a. Okay, so we have that 3 and we have a plus the constant of integration c, and this is nothing but your final result. Wasn't it the cleanest solution that you have ever seen?